So we been to chi-square a little bit. We started it. We looked how it's done. Now let's take a look at other examples and what is that kind of p-value tell us about. So let's take a look at this example, one that I kind of finished before the video I saw was 9 minutes, so I thought it would be a good idea to make another one. So let's see here if we have two things we're looking at, the shift number, one, shift two, if something passed or something failed. Let's say we're looking at the quality of a product, right? And in this case, I created a table in a way that exactly you have four groups, right? Is exactly 25% in each one of them, right? So half of them passed, half of them fail, half of them shift one, half of them shift two, in exactly same way. So what you expect is there's no impact on shift and pass and fail, right? Because they're exactly the same number. So if you do the use this table to calculate expected, it'll be exactly like this. And if you calculate chi-square, it'll be exactly like this. So all of them will be 0 and your p-value will be 1. So if the p-value is very high, okay, close to 1, because 1 is 100%, that's the highest it can be, it means that there's nothing going on. They're basically the same. They don't depend on shift or pass or fail or whatever it is, or GSCOM, not GSCOM, because they're basically exactly what they expected to do, expect it to be. What's happening here, as you can see, we put the same number 100, 10% pass on shift 1, 40% fail on shift 1. Now shift 2, 40% pass and 10% fail. So you can see there's a big difference, right? Being shift 1, you're probably going to fail. Being shift 2, you're probably going to pass. So you can see that there's a big difference. The expected table, that's the same for those two cases, right? Because it's 50-50 and 50-50, the sum doesn't change here and here, right? I'm just putting different places. Since the sum is the same, the expected will be the same because it's this times this divided by this, and the numbers of the sums are all the same. But when I calculate chi-square, the chi-square becomes huge, 36. And with 1 degrees of freedom, that gives me a p-value of 0. So whenever there is a big difference between one group and the other group, the p-value will be low, and you just learned the last video. If the p-value is low, the no must go, right? So the no must go because there is a difference between those shifts. So what I want you guys to do now is to take a look at this example. We have a management science department, it has two professors that teach business process management. Many students believe that Dr. Jensen is harder than Dr. Ahiri, and suggest that failure rate is higher for a particular professor. Is that correct or not? So you have here Dr. Ahiri students, here Dr. Jensen students. Oop. Take this and put in Excel, how many has passed, how many has failed, and create this table and fill out this table with this is the actual table, do the sums, do the expected ones, do the chi-square, degrees of freedom, p-value, and conclusion, and I'll take a look at what you guys done on the next class. Finally, we have one kind of important thing here at the end, which is a quick guide to all the tests. So here we have the test, what it is, what is tell you if the p-value is lower than 0.05, what is tell you if it's higher than 0.05, what is the test we did, and we went over what is it telling you for all of them, okay? And this is what we have for the analyze phase. So I know you guys love statistics so much, but we're not going to see much until at least the end of these videos. We're going to keep, we're always coming back to the stats later on the day, but it's going to be more in the control phase where we're going to do some more of that cool math, okay? So see you guys in the next video. We're going to go into implementation and control. So still have a lot of good things coming our way.